Problem 10. How many arrangements of A, B, C, D are there in which no two adjacent letters are also adjacent letters in the alphabet? So A, B, and BA are not valid solutions. Well, consider A, B, C, D here, right? If we don't want A, B, C, D to be alphabetical, then that means A cannot be next to B. So A can be next to C or D. B can be next to, B can only be next to D, right? So we have one very restrictive case here, but let's continue. C can be next to A or D, and then D can only be with B, right? Or A. So the most restrictive case here is B, right? Because B, right, has two neighbors, and so it can only be with D. So that means that if we were to consider this, we can only have BD, right? We can have BD, or we can have, BD. And obviously, by symmetry, we can swap the places. So let's just fill it in. If that's BD, we can do AC. We can put AC. We can put AC. Now let's consider the cases. B is not next to A or C. That's good. D is not next to C, which is good. A is not next to B. C is not next to B or D. So boom, we have a bingo case. Oh, actually, by symmetry, right? C has two neighbors. So C can only be with A. So actually, we only have two solutions, because just by the restrictive cases, this won't work, right? No matter how you swap it, because we remember, we always look at the most restrictive cases first. So if you do this, C and B gets together, so this is wrong. We can have this case, or we can have this case. But then again, what's stopping me from saying D, B, A, C? Well, boom, look at that. A and B are together, so you cannot swap these two. Likewise, you cannot swap these two either. So by symmetry, this cannot be swapped either. So you have 1, and then you have 2. So your final answer will be answer choice C.